Hi, so this is section 17, radical expressions and functions, and we'll divide this topic into two videos. The first video, I'm going to go over the explanation of radical expressions and how to find the domain of radical functions. Before we go into evaluating these expressions, let me explain. You can read this a little bit later if you want, but I'm going to explain to you exactly what this means to clarify. So a radical expression is an expression, oops. Okay, go back here, scroll up. Okay, so a radical expression is an expression that is inside this symbol. Okay, the symbol itself is called the radical. There's a number that goes here called the index. The index is going to be any number 2 or bigger, only a whole number, 2, 3, 4, 5, 6, and so on. It's called the index. And then there is either a number, I'm going to call it A here, a number or a variable inside of the radical symbol, and that is called the radicand. Okay? So whenever you don't see a number for the index, the default is 2. So for example, when we have something like this, we normally know how to read this square root of 9 or radical 9. We don't see a number for the index, so the index is 2. Now, to find the answer to this, we need to find a number, and I'm going to represent here by a box. That's going to be multiplied by the same number. So both of these numbers have to be the same. And when I multiply both of these numbers, I get the number inside of the radical. So take a look at square root of 9. Can you find out what's inside of the box? Remember, it has to be, each of these two boxes has to have the exact same number. And then when we multiply those two numbers, we get 9. So if you guessed 3, it's correct. So then that means that we can say that the square root of 9 is 3. Because 3 times 3 is equal to 9. How about 25? Okay, I'm going to put the two boxes here. So again, this is index 2. I need a number that goes into the box, and they have to have the exact same number that multiplied gives me 25. Yes, so if you guessed 5, it's correct. That means that square root of 25 is 5. Now, how about if I have something like this? Cubic root, so now the index is 3, of 8. Now, in this case, I need, because this is 3, I need 3 boxes. And the number that goes into all of these boxes has to be the same. And after I multiply them, I have to get 8. So which number is inside of the box? Yes, so if you said 2, it's correct. So we can say that the cubic root of 8 is 2. So this is the idea of radical expressions. They get more complicated, but we're beginning section 17. And this is what we need you to understand. We need you to understand that the symbol is called radical. The number that goes on the upper left side of the radical is called the index, can only be a whole number 2 or bigger. The number or expression that goes inside of the radical is called radicand. In order to find the value of a radical expression, if it is the square root, we need the same number multiplied by itself twice. If it's a cubic root, the same number multiplied by itself 3 times. If it's a fourth root, 4 times, and so on and so forth. So let's take a look at the examples we have here. We won't do all of them, but we can do some. Make sure you understand the procedure. Some of these are very easy. I already did, square root of 25. Let's take a look at square root of 64. So I know it's square root because there is no number right here. There's an invisible 2. So the square root, we don't put the number 2. We consider it as a default. Any other number we write in. Like, for example, here, cubic root, fourth root, fifth root. Okay, so I'll do 3 of these, and I guess you can do for practice the rest. So let's take a look at the first one. So square root of 64. So again, I need 2 numbers, identical numbers, that multiply together, giving me a 64. Okay. 8 times 8. Right? That's 64. So square root of 64 is 8. Now, notice that, let me just check. If I do right, 16 times 4, that is also 64. But that doesn't work because the 2 numbers in the box have to be the same. So the answer to square root of 64 is 8. Same thing here, but now in this case, I have a minus in front of the 81. So I do the boxes first, right? And I know it's 9. 9 times 9, 81. So the answer to this is the 9 with this minus in front. Okay. So the minus square root of 81 is minus 9. Let's take a look at, we already did 1 cubic up here with cubic of 8. So I'm going to skip this one for now. And let's take a look at this one right here. This is the fourth root of 81. So I need 4 boxes. Right? Why 4 boxes? Because this is a fourth root. And that has to equal 81. So which number goes in the box? And all of the boxes have to have the same number. So if you said 3, 3 is correct. 3 times 3 times 3 times 3 is 81. So the answer to this is 3 with this minus in front. And let's do this one. Okay, so now this is negative 64, but it's cubic. So I need 3 boxes, which I'm going to multiply. And the boxes have to have the exact same number, and it has to be minus 64, the product. So which number is it? Yes, so if you said minus 4, it's correct. The answer is minus 4. Okay? So this is how you evaluate basic radical expressions, either square roots, like this problem, 17.1, cubic roots, like the problem we saw here, cubic root of 8 in my example, fourth roots, or even cubic roots with a negative number inside. Okay, now let's take a look at the other thing that we have to do, which is be able to find the section itself has a little brief introduction into graphing these roots. This is the square root, and this is a cubic root. We won't need much of that. You can read it later. And I'm trying to make the video a little shorter, so I'm not going to spend so much time on that. But we need to be able to, this is very important, we need to be able to find the domain of a square root function. So a square root function is a function that has the radical symbol in it. And the way that we're going to do this is to get the radicand. We're going to set it to greater than or equal to 0. We're going to solve it for x. And then the answer, as you see here, has to be expressed in interval notation. It's very important because the answer is going to be an infinite set of values. So let's take a look at the problems that we're going to do. So I will do 2. I have 2 here, and you can do the other 2 later on if you want. So I have a radical function, which is f of x equals square root of 3x minus 12, and I need to find the domain. And keep in mind, the answer has to be expressed in interval notation. So step 1 is I'm going to set the radicand, the expression inside of the radical, to greater than or equal to 0. Always greater than or equal to 0. And then we're going to solve this inequality. We already know how to solve it. So I'm going to add 12 to both sides. And we're going to divide everything by 3. So this is the numerical answer. X greater than or equal to 4. This is the numerical answer. This is not the exact answer format that we want it in. So now we have to write it in interval notation. So here's the graph. We don't need the graph. I'm just doing it here so that you can use it to do the interval notation format. So plot the point that you have, which is 4. And because of the equal sign, this is a closed point. And then you're going to shade it in the direction of the inequality, which is to the right. Okay, so the red segment is your solution. Okay, so now we look at the graph and we write it in interval notation. So remember, when this point is closed, I use a bracket, 4, and it's going toward infinity. So I write infinity here, and positive and negative infinity, you always use the parentheses. Okay, so this is the domain. So on your exam, if you have a question like this, and you will write domain is bracket 4, comma, infinity, parentheses. All right, so let's do another one. Oops. Okay, so let's do another one. Okay, and you can do it ahead of me if you already know how to do it. So here is a radical function. I am going to set, be very careful with this one. This is a very good problem. That's why I picked it, and set it greater than or equal to 0. Now we're going to solve this for x. So minus 10 on both sides, right? We need to isolate the x. And we are going to divide everything by negative 2. Now, here's one thing that you must remember. So the minus 2 cancel. Minus and minus becomes a plus, 10 divided by 2, 5. But because you've divided by a negative number, what happens to this symbol? So if you said greater than equal shifts to less than equal, you were right. Okay, so whenever you divide or multiply an inequality by a negative number, the inequality that you're using changes sides. So here is your solution. Be very careful with this problem. Okay, so now I am going to do the exact same thing I did before. I'm going to graph it first. So 0, I'm going to plot the point, which is 5. And it's always going to be closed. So here's 5. And I'm going to shade it in the direction of the inequality, which is to the left. So the red segment, the red line right here, is my domain. So all I have to do now is write the domain in interval notation. So this is obviously negative infinity. It doesn't stop because of the arrow. So negative infinity, comma, 5, and it's closed. So we put a bracket on it. Okay, so this is how you solve and find these domains of radical functions.